Hello everyone and welcome back to our videos. Today we will talk about Fire Protection System, Chapter 16, Airframe book. Since fire is one of the most dangerous threats to the safe operation of an aircraft, so manufacturers and operators install a variety of overheat, fire detection, smoke detection, and extinguishing devices. In section A, we will talk about the fire detection and its types, also the components of every devices of fire detections. And we will talk about also the smoke detection and its types and operation. In section B, we will talk about the extinguishing devices and the types of agent that used in the extinguisher bottles and how to use. To maintain the highest level of reliability from these systems, a technician must be familiar with the basic operating principles, troubleshooting, and repair of the various types of fire protection devices used on modern aircraft. And that's what we will study in this chapter, how to understand the basic operating principles and how to make troubleshooting and repair of the various types of protection devices like the fire detection, smoke detection, and extinguishing devices. We will start with section A, fire detection. On early aircraft, the task of detecting smoke and fire was reasonably easy because the pilot could see most areas of the aircraft from the cockpit. However, as larger and more complex aircraft were built, it became nearly impossible for the crew to observe all parts of an aircraft, and smoke and fire were often not detected unless the hazard was beyond control. To resolve this problem, modern aircraft have overheat and fire detection systems installed to provide an early warning of hazard, so the crew can take appropriate actions to reduce or eliminate them. So the fire detection system and the fire extinguisher system helps to find the hazard and solve it and eliminate it. Before we talk about the fire detection system, principles of fire detection systems. For a fire to occur, three conditions must be met. There must be fuel, oxygen, and enough heat to rise the temperature of the fuel to its ignition or kindling point. If any of these elements is missing or removed, fire will not be sustained. That means if, for example, the fuel missing, the fire will not occur. Also, if the oxygen will removed, the fire will not happen. And the same thing about the heat. If there isn't heat and there is fuel and oxygen, that means there isn't fire. Classes of fire. To understand how and why different types of fire detection systems are better suited for certain application, you need to be familiar with the classification of fires. as identified by the National Fire Protection Association. These fires are identified in conjunction with the types of material consumed by a fire and are assigned different litter classifications as follows. The first class is Class A fire. This class is one in which solid combustible material burns, such as wood, paper, or cloth. The second class, Class B fires, are composed of combustible liquids such as gasoline, oil, jet fuel, and many of the paint thinners and solvents used in aviation maintenance. On an aircraft, these classes of fires typically occur in engine compartment or nacelles, and in compartment that houses an auxiliary power unit, APU. The third class, Class C fires, are those that involve energized electrical equipment. These fires require special care because of the dangers from the electricity. Since the initial stage of electrical equipment fires are usually preceded by large amount of smoke, these areas of an aircraft are generally monitored by smoke detection systems, like the avionics compartment bay. The fourth class, Class D fires, and this class involve burning metals such as magnesium and are difficult to extinguish. Using the wrong type of extinguishing agent with these fires may not only be ineffective, but may even cause the fire to spread. Although these types of fires are not common in aircraft during flight, they can occur in maintenance shops where metal shavings may ignite when exposed to intense heat, such as from a welding torch or high voltage source. After we understand the classes of fire, we will study the fire zones. Various compartments in an aircraft are classified into fire zones based on the amount of characteristics of airflow through them. Fire zones are primarily classified by the amount of oxygen that is available for combustion and are identified as Zone A, Zone B, Zone C, Zone D, and Zone X. We will start with Zone A. The A zones have large quantity of air flowing past regular arrangement of similarly shaped obstructions. The power section of reciprocating engine is a common example of this zone. The Zone B zones have large quantities of air flowing past aerodynamically clean obstruction. Heat exchanger ducts and exhaust manifold shrouds are usually of this type. What about the third zone? C zones have relatively low airflow through them. An auxiliary power unit compartment is a common example of this type of zone. The Zone D zones have very little or no airflow. These include wing compartments and wheel wells, where little ventilation is provided. The last zone we will talk about is X zones. They have large quantities of air flowing through them and are unusual construction, making fire detection and uniform distribution of an extinguishing agent very difficult. Fires in Class X zones will need twice the amount of extinguishing agent normally used in Class A zone. After we understand the zones, I will tell you why we study the zones and the classes of fire. We study them because when we study in section B the fire extinguisher agents, you will say we use some types of extinguisher. It will use Class A, and some of the agent that used in fire extinguisher it will use in Class B. So you have to understand the classes and zones to understand the type of agent you will use in this zone and these classes. The last thing we will study today, the requirements of overheat and fire detection systems. Modern detection systems have been proven to be highly reliable when properly maintained. These systems consist of electrical or electronic sensors that are installed in remote locations. The sensors warn the operator of impending hazards by sounding an audible alarm and illuminating a warning light that indicates the location of the hazard. Before these systems are approved by the FAA, the Federal Aviation Administration, for installation in an aircraft, the manufacturer must prove that the fire detection system design meets the following criteria. So the 9 steps or the 9 descriptions we will study now, they are the requirements for the fire detection system to will be installed on the aircraft. So that means the 9 requirements must be proved on the detection system that will be used on the aircraft. The first requirement is the system must be constructed and installed in a manner that prevents false warning under all flight and ground operating condition. That means the fire detection or smoke detection must be doesn't make a false warning in all conditions unless the aircraft on flight or on ground. The second requirement, there must be a rapid indication of fire and an accurate indication of the fire location. Our detection must give a fast indication of fire and also must indicate the location. The third requirement, the system must have an accurate indication that the fire has been extinguished. The detection system must give us an indication that the fire is extinguished. Number 4, the system must automatically reset once a fire is extinguished to provide an immediate indication if a fire reignites. That means the fire detection system must reignite itself after the fire extinguished, because if the fire it will make another time or it will reignite another time, it has a detect another time for alarm the captain. The fifth requirement, when there is a fire, there must be a continuous indication for its duration. That means the audible or light indication must still until the fire, what we say, extinguished. The sixth requirement, the detection system must have a means for electrically testing the integrity of the detection system circuitry from the cockpit. That means the detection system must have a test from the cockpit to test that the system is ready for use or not. Number 7, the detector or sensing units must be able to resist exposure to oil, water, vibration, extreme temperature, and maintenance handling. That means our detector must resist the oil, the water, and the vibration, also the high temperature and the handling. Number 8, each detection system must actuate a cockpit light indicating location of the fire. That means the detection must give an indication light for the location of the fire in the cockpit. And the last requirement, in case of multi-engine aircraft, the detection system must consist of a separate sensing circuit for each engine. That means every engine must has a detection system.